Hi girls, we're going to have a look at an introduction to trigonometry. Trigonometry is just the study of the relationship between the sides of right-angled triangles, and without going into too much detail, trigonometry is used in lots and lots and lots of mathematical and scientific applications, ranging from engineering to environmental studies. But the first thing we need to learn when we're talking about trigonometry is some names. We've talked already about how when we have a right angle triangle like this one here, the longest side, which is always the side opposite the right angle, is called the hypotenuse. So we're familiar with that term. The longest side is the hypotenuse. But let's say I'm interested in one particular angle on my right angle triangle. I'm going to call that angle A. I'm standing here on A. If I look straight ahead of me at the opposite side, I would call that the opposite. And if I look at the side that's next to me as I stand on this angle here, the side that's next to me that isn't the hypotenuse, that's going to be called the adjacent side. So you probably have noticed that if I change to another angle, say I'm interested in this angle here, then the opposite side would become this one. Let's have a think about that. There are three trig ratios, or three trigonometric ratios: the tan ratio, the sine ratio, and the cos ratio. And we find those ratios by dividing certain lengths of triangles. So the tan ratio is found by dividing the length of the opposite side by the length of the adjacent side. So we write it as tan equals opposite over adjacent. The sine ratio is found by dividing the length of the opposite side by the length of the hypotenuse. So we say sine is equal to opposite over hypotenuse. And the cos ratio is found by dividing the length of the adjacent side by the length of the hypotenuse. So cos is adjacent over hypotenuse. And lots of people use this funny word here to help to remember that, SOHCAHTOA. If I spell out SOHCAHTOA, I can see that the S stands for sine, and then straight after the S is an O and a H. Sine equals opposite over hypotenuse. C stands for cos. Cos equals adjacent over hypotenuse. And T stands for tan. Tan equals opposite over adjacent. So to help you remember these ratios, you can simply remember that word, SOHCAHTOA. That's very helpful. Okay, let's have a look at an example here. Here's a nice right angle triangle, and I'm interested in this angle here called theta. So first of all, if I look at this triangle, how long is the hypotenuse of this triangle? Well, it's nice and clearly written there for me. It's 26 centimeters. Now it gets a little bit trickier. How long is the opposite? Well, if I'm standing over here on theta and I look out, the side opposite me is this side here, which is 10 centimeters long. So how long is the opposite? It's 10 centimeters. And if I stand at theta again, always have to be standing at a particular angle, or with reference to a particular angle. Here I am on theta. What's the side that's next to me or adjacent to me? that isn't the hypotenuse? Well, it's this one here, 24 centimetres. So 24 centimetres is the length of the adjacent side. So if I want to find tan of theta, I remember that tan is equal to what? Opposite over adjacent. I'll just write it shorthand. Opposite over adjacent. So in this case, opposite is 10 centimetres and adjacent is 24 centimetres. So I could put that as a decimal using my calculator. Clear. 10 divided by 24 is equal to 0.416666, so we'll just call it 0.417. Oh, sorry, just looking up there. Okay, let's have a look at sine theta. If I want to find sine theta, I have to remember that sine is equal to opposite over hypotenuse. So the opposite is 10 centimetres and the hypotenuse is 26 centimetres. So again, just putting that into my calculator, 10 divided by 26 is equal to 0.3846 blah 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 blah. Let's just call that 0.38. Oh, let's do that. 0.38. And if I want to find cos of theta, I have to remember that cos is equal to adjacent over hypotenuse, which is equal to, the adjacent side is 24 centimetres and the hypotenuse is 26. So 24 over 26, which is going to give me, using my calculator, 24 divided by 26 is equal to 0.92, let's say. Okay, so that seems pretty straightforward. Another thing to notice about trig ratios is that if the angle stays the same, then no matter how big or small the triangle is, the trig ratio will also be the same. So here I've got 3 triangles and they each have the same angle theta there. So if I find tan theta in each of these 3 triangles, I'll find that tan theta is always the same. So tan theta in triangle A is 5 over 12. Tan theta in angle B is 10 over 24. Tan theta in triangle C is 15 over 36. And all of these ratios simplify to the same number, 0.417. Let's look at sine. Sine is opposite over hypotenuse. So sine of theta is 5 over 13 in triangle A. Sine of theta is 10 over 26 in triangle B. And in triangle C, it's 15 over 39. And all of those ratios are equivalent to 0.385. So no matter how big or small the triangle is, if the angles are the same, then the trig ratios are going to be the same.